And you can see me, yeah?
Yes.
Great. Yes. Simply because, Panopto sometimes causes flashes. So I think I've sorted it, but let me know if something goes wrong, please. Okay. So before I share the slides, anyways, we still have a couple of minutes, so let me wait for everyone to sit, and then we will get going. All right, let's get on. Before I load up the slides, I just wanted to show you progress on the paper allocation. I see that still there are a couple of papers, 3 at least, number 3, number 4, and well, there's paper 15 who only has 1, and paper 7 also just 1 participant. So most of you have booked themselves into these, but the papers 3 and 4 are still empty, so you have until today. End of today to self book your place. Okay, so if there are no questions about this rather technical aspect of the presentation, I will share the slides. Okay. Slide sharing doesn't work, so we'll do it this way. So, you will hopefully remember that towards the end of last lecture on Tuesday, we tried to reason about what could change if you were to make the standard model a bit more complex and accommodate some degree of altruism or social preferences from the point of view of the players here. We're concentrating on Anil's payoffs in this game about choices with respect to what crop to plant, right? Remember that you could pick between rice and cassava. The 2 players have different degree of specialization in the two crops. So they would have a preference, but you may find yourself stuck in the miscoordination equilibrium. Right? Here, instead, you briefly mentioned the prisoner's dilemma and the fact that you may end up on using too much pesticide. That's the terminator-terminator strategy, which again is a situation of Pareto-dominated equilibrium, because both players would be better off using less pesticide. So that will be the prediction if you have indifference curves that are vertical, like here. Of course, from the point of view of Bala, they would be shaped in that direction. And we have seen that if instead Anil has some kind of curvature in the indifference curves, meaning he trades off, is willing to sacrifice and stay at the same level of utility, for instance, point C with respect to point B, by having less income, 6,000 rupees instead of 7,000, but an extra 2,000 rupees going to Bala, then you can actually sustain the better equilibrium. And we see diagrammatically that that means ending up on the II equilibrium here, which has, as we have seen from the payoff function, which I pasted here, which is 3,000 rupees for each of them. So to do that, you need some kind of some level of social preferences. That's one way to resolve the prisoner's dilemma. Let's look more generally about other departures from the standard model. Inequality aversion specifically allows to in your utility function to capture the payoff of others, but in two very specific ways that are empirically backed to some degree. They have been tested in the field and in the lab. And the idea that you associate this utility term both to being worse off, right? You have some level of envy for the player that is better off, but also in the positive domain. So that's known as advantageous inequality aversion, right? You are better off, and in a way you suffer a cost in terms of utility because you feel bad, perhaps. Another common finding in the literature is that we exhibit some degree of reciprocity, right? We tend to reciprocate kind acts, but also we tend to reciprocate spiteful or non-cooperative acts. That, at a larger scale in the society, can lead to so-called conditional cooperation, where we're neither stubborn cooperators or stubborn defectors. We're probably some, or most of us, are somewhere in between. Our actions depend on our perceptions about how many people in the population, for instance, exhibit the cooperative choice. And if we feel that enough are doing their part, say enough people are recycling, enough people are investing in effort and time and money in order to reduce their impact on the environment, then we're more willing to also do the same. Right? That's conditional cooperation. So in terms of societies, we talk about social norms when people assess or evaluate whether society at large is inclined to do the helpful or kind gesture, and a social norm can loosely be defined as a common understanding of how to act in situation when one's actions affect others, right? So this entire lecture is about interdependence and social coordination. So social coordination is very much linked to social norms. All of the above make us play differently both in public goods games and where there's just one equilibrium, or in more complex distributive games such as the ultimatum game. This is a good way to transition to the class of games known as repeated games. So far, all the type of interactions, say the ones between Anil and Bala, have been of the one-shot kind, meaning we meet only once. Most likely we don't know one another, we meet in an anonymous form, and we interact in a one-shot game, say the prisoner's dilemma game, and then the coordination game we saw, and then that's it. You get paid according to your performance. But in real life, oftentimes we interact repeatedly with the same people or in the same situation. So this class of games is very important and they have been found to be helpful, just playing the same type of game, say 10 times instead of one shot, in order to stabilize cooperation. This is again related to the impact of social norms, of tendencies such as an inclination to reciprocate kind acts, but also another mechanism that we haven't really discussed yet is that of peer punishment. If in these games, since you play repeatedly, you can build a reputation, right, for either being, say, a cooperator or a defector. That may have payoff consequences. So even in a world where people are selfish and rational, the threat of being punished by others may justify acting more cooperatively. We will come back to this important point. So behaving selfishly in one period has consequences in future periods, in repeated games, so it may no longer be a dominant strategy, right? Remember before we were just assessing what's best to me, given this one period of play, because it was the only period of play. Now, let's look at experiments that have actually been played elsewhere. As I said, in future lectures, we will also play our own and see whether we can find some predictable patterns in our behavior. So here, there's a decision to be made about, it's a public goods game, because there's more than 2 players. And in fact, there are 4 players. So this kind of diagram is quite useful to represent this kind of greater than 2n type of player games, because you see you have on the x-axis the number of other farmers contributing to this irrigation project. So 0 means that you know, from your point of view, if you were to cooperate, you would be alone, right? 1 means that one other person is cooperating, 2, and 3 means that everyone else in your group is actually investing in the irrigation project. So there are 4 farmers. Each farmer decides whether to contribute to the public good or not, which is costly. Contributing as a personal cost, and it has, importantly, the positive externality. Everyone benefits, the spillover effects. So you shouldn't be surprised that in strategic terms, there's only one dominant strategy, that's the free riding one of choosing 0. Why is that? Let's compare from Kim's payoff point of view. So assume you are in the shoes of Kim, and you're computing payoffs for yourself given the action of the others. If no one else cooperates, you would actually make a loss if you're the only cooperator. That's because you're investing in this irrigation project, but since it's only you, it's not really doing much, and you're just bearing the cost all yourself. Here, at least, the calculus is positive, independent of the strategy you choose, because the idea that the more people cooperate, it's a public good, right? So there's gains to be made by all. But notice that the tendency is still to switch to not contributing, because you can make an extra $2 payoff. So the dominant strategy would be to not contribute, given that one other contributes. Same applies though for 2 and 3, right? So of course things get increasingly better from the society point of view. In fact, so good that it doesn't matter much in the end if 3 other players participate, because you're very close to the social optimum. But still, individually, you have an incentive not to contribute. And you know that type of reasoning where it leads, you know, because the others, assuming rationality, do the same reasoning. So you will end up in the 0, 0, 0, 0, meaning no one is contributing and everyone is getting a 0 payoff. That's what happens with standard preferences in this game. Questions or comments? So let's see how people play this type of game. So here's this study has been replicated, as I said, across societies. Here's one attempt to a meta-study that looked at exactly the same experiment, but done in different cities throughout the world, in different continents as well. I think that it was done with students, but I should check, because it has also been replicated with non-students population, which increases its external validity. But the main point is that however you do it, you find more or less this kind of pattern. Of course, it does matter, that's the first observation we can take home, whether you are a Danish subject in Copenhagen or not necessarily Danish, but living in Copenhagen, or someone living in Melbourne. You see that these are ranked. So on average, these groups tend to be in the Danish ones, but not only, all these in the top part tend to be the most cooperative compared to the bottom 4 or 5 cities that tend to contribute less. That's observation number 1. Observation number 2 is that still the pattern is qualitatively similar across the board, right? You have, even in the most cooperative societies, you have a negative slide towards the non-cooperative equilibrium, the dominant strategy, but not all the way there. So I guess that's the third bottom take-home message here, is that you don't get to 0. Note, this game was played over 10 rounds, and I think subjects were informed that the game would end, so there would be no further reputation benefits from cooperating in the last round. So in this type of games, it is quite common to observe a dip in the last round. So perhaps it's more informative to look at the penultimate round. Anyways, you see they go towards the Nash equilibrium, but not quite there. Well, some like the people in Istanbul and Melbourne almost get there. They're probably on average contributing just 2 out of 20, I think, was the maximum. But see how, you know, against the predictions of the rational model, see how high things are here. 8 means that that people were contributing, even in the lowest contribution cities, about half of their endowment and close to all of it in other societies. So what's the main message here is that people tend to be conditional cooperators. They contribute so long as the others also invest some of their money. So that's why it's easier to be a contributor here, because everyone else is doing their part. And this has sort of a positive feedback effect. That's the role of social norms. You see how important they are, how different people play in different societies under different expectations about what is the sustainable or acceptable level of contribution. Now, what if we introduce punishment? Because, you know, this is, in a way, you can read it in a positive light, but if you focus on the second part of the game, you know, especially the last couple of rounds, you know, it's not so great, especially for some of these groups. There is this slide towards defection. So can we actually find a mechanism that sustains cooperation all the way, even in the last period? And you see, across all these different cities, the game was again done, but with a twist. A second stage was added. So we will play variants of this game, but the setup is the same. You play in 4-player groups. You're anonymously matched. Imagine here you're partitioned in different cubicles. You don't know who you're playing with. Maybe it's someone connected remotely from Teams at home. Maybe you're all sitting in the same row, unlikely, but that's the type of interaction, and you choose your contribution in each round in an anonymous fashion, but associated with your player name or number, say. So people know that if you are player 2 in a group of 4 and you continue to defect, you know, you're probably developing a reputation. Why is it important? Because after the contribution stage, unlike in the previous game, here there's a second stage where the same players are asked, how much of your endowment do you want to, in this round, do you want to invest in punishing all the other players? So in principle, you could punish everyone else. You could punish nobody. That would be the dominant strategy if you're rational, because it's costly. So in a way, you're providing a public good by punishing, say, defectors. But again, there's evidence that people do punish. And in the end, maybe it doesn't even matter, but just the threat of punishment helps with cooperation, because potential defectors, non-conditional cooperators, might rationally anticipate that they would incur a cost if they defect too much. So that helps. I must add that this type of games generally are structured in such a way that even if it's costly, it is quite efficient to punish, because it's not one-to-one. So if I use some of my endowment dollars to punish him, say, for each dollar I invest, he will be punished twice as heavily. So my dollar becomes $2 in terms of punishment. So you see, it is done in a way that favors punishment. But still, it's remarkable to see that even in such a game where still the dominant strategy would be to not contribute, in all cities pretty much the contribution didn't decline. In fact, in some cases they even increased, at least temporarily. Then they plateaued, maybe a minor dip in the last round, but remember the last round is not super informative. And anyways, I don't see much of a trend, neither upwards, if anything a little bit upwards in some groups, but certainly I don't see much of a negative trend in terms of decreased contributions. So some start at 30% of their endowment. Remember, endowment is 20. Some groups clustered around 50%, others, the usual suspects, the Copenhagen group, for instance, started close to or above 75%, and they stay more or less where they are. So that's important of peer mechanism, and of course in societies we observe some degree of these mechanisms at work. So it has some important conclusions also for policies and both local commons management and more global dilemmas. Any questions or remarks?
Can you come back to the previous slide?
Yeah.
What if people have a fake perception of the share of people who are actually contributing to the project or to the public good? Because in this case, it seems that we know for sure which is the percentage of people contributing, but if we have fake perception about this data, I think it's going to change.
Okay, that's a good point. So if I understand, correct me if I'm wrong, if I understand well, you're saying what if we do not have full information about contributions in each round? Because to remark that in each round here, you don't know that, for instance, he contributed that amount, but we know that what each player, wherever they may be, online or here, each player in your group contributed X. So that's quite a special case, perhaps, if we consider anonymous online decision and other type of public goods that may be played in these settings. So yeah, it can be played without full disclosure. So for instance, you could do it in such a way that you play all 10 rounds and only learn in the end what was done. Of course, you know, it's a matter of what problem you have in mind. I would argue that generally you have some kind of, you know, notice that this is anonymous, right? We don't know who is doing what. So it's still quite basic, the level of information people have. Also, we are depriving them of any coordination mechanism such as chat. You know, you could play the same game without punishment, but with allowing people to chat after contributions, for instance, among them four, and this has been done, and this also promotes cooperation. Maybe not as much as punishment, but it certainly reverses some of this negative trend. So yeah, it really depends on what you want to capture, but in reality, at least at the society level, you know whether the public good is unfunded, right? You know how much progress you're making towards that public good. If schools, you know, there's not enough taxes being paid that schools cannot deliver their services, or you cannot build a bridge, or you cannot mitigate climate change, you generally, with some uncertainty, you know. But we will come back to this important point. And the bottom line is, the more uncertainty about others' contributions, the less the contribution. So it does bring things down. Any other questions? So we'll probably revisit that also when we play these experiments in class. So far we have looked at either the prisoner's dilemma, the public goods game, or coordination game. Let's look at a different kind of sequential game known as the ultimatum game. That is also important because it has the element of time, but unlike in the public goods game repeated over time, where things are more or less symmetric, right? Everyone moves simultaneously in each round. Here, actually, it's the moves that are scattered over time. So you give bargaining power or an advantage of first mover to the proposer in this case, and then the responder, you see, moves only after the proposer has made her choice. So in this very simple ultimatum game, which is a special case of a more general one where the choice is free among many levels of contributions or sharing, here the proposer gets to choose only between two types of offer to the second mover, either a 50-50 split or an 80-20 split. So you see the first payoff is the one accruing to the proposer, and the second payoff is the one accruing to the responder. So this is a situation where there's money to be split, there's a gain that has been made and has to be divided up, but the proposer moves first. So many real-life situations involve some kind of decision like that. But note that this is not a sort of dictatorship in the sense that then the responder does have some kind of choice. He could reject, in which case both players go home without any income, or could accept the split. Then of course it depends where you are on this tree. If you are on the left-hand side, meaning that the proposer chose to sort of do the equal split, accepting means going home with 50-50. Otherwise, accepting means that the responder only goes home with 20 euros and the proposer goes home with 80 euros, right? So you see there's a lot playing into this game, also from the perspective of distributive justice and altruism, right? Again, if you are of the selfish, rational kind, your utility of choosing only depends on your own income. So let's call your income X, then for player one, for the proposer, then U of X really is maximized by going right, by offering only an 80-20 split. Why is that? Remember that each player has to reason through what the choices of the other player will be. But if player one is rational and assumes that player two, the responder, is rational, you can start from the bottom, right? So responder would, between rejecting or accepting, even this kind of unfair split, if rational, would always choose accept, right? So you know that proposer knows that responder will choose accept, both here and here, depending on which branch the responder is. But of course, given that it is in the hands of the proposer to choose the branch, it will go this way. However, as you can guess, due to altruism, fairness, inequality aversion, the presence of social norms and reciprocity norms, the real outcome probably varies when we look at how it is played with real people. So let's look. This is an interesting case, I think, because it was done with two samples. Remember, there's the weird students, the Western rich democratic country population that is often used, and this is from a US university in blue. They play this same game of choosing, your contribution to this irrigation project, and then they also play this irrigation project game, which is really a public goods game, with actual farmers in Kenya. And you see, that you can already appreciate that the two groups behave differently, but certainly they don't seem to play according to standard rationality only. At least there seems to be some level of social preferences in both populations, but also not all the way, so there's also some selfishness in a way. How do I mean that? So let's look at the graph in more detail. Here on the x-axis, you have the fraction of the pie that you are to split. So you are in the responder's shoes that the in the proposer's shoes that the proposer offers to the responder, right? So we just stop at 50 because I think no one proposed more than 50%. But in principle, a very altruistic proposer could offer 40-60, say, so to give more than half of the pie to the responder. Didn't happen here, it's quite unlikely, but in principle, no one stops the proposer from making such a generous offer. And on the y-axis, we have the fraction of proposers making that level of offer. So, for instance, this would be the very selfish proposer, right? Saying, you know, I propose that I keep everything and you keep nothing. Now, using social preferences, you can actually rationalize that this is going to be unlikely, and that's why we have different shades in this chart. The darker red and darker blue shows the proportion of offers that are expected to be rejected given some level of degree for care about your good and the others' good. So basically, not many people chose to offer so little, and it was more common behavior among the students. They seem to be more aligned with the selfish model, but still less than 20% of the cases. And the prediction is that then the responder would say no thanks, right? Because from the responder's point of view, you go home with zero whichever way. So why would you accept? Now, with a very small offer, again, depends on how rational players are, but you would expect still quite a lot of responder rejection, which actually materialized. And I guess the more interesting cases are 20, 30, and 40, which saw quite a bit of proposers going for those, again, with some heterogeneity among the groups. So, for instance, again, there were more students that proposed this rather selfish split of 80-20 than farmers. Now, this was the model choice for students, 70-30. And we see it's still not super popular among the farmers. And again, this shaded area tells us that Kenyan farmer responders are expected to reject a 30% offer about 50% of the time. Now, this definitely is the one that was chosen the most, 60-40, by the farmers, and it is expected that pretty much no farmer in the shoes of the respondent will decline that. And this was relatively unpopular with both crowds. So quite a bit of heterogeneity and quite a bit of mix. Probably some people in the two populations are of the sort of clear, true, stubborn type, but others are more have reciprocal preferences. Now, this slide is also interesting, I think, because it drives home another important point, that the rules of the game do matter, right? We have already seen it when we discussed before. If the game would be played differently, that was the public goods game, if there was partial or no information about the payoffs in each round. Now, here we assume there's some level of competition, meaning that the proposer, all that suffices for the deal to be signed is that one responder among two accepts the offer made by the proposer. So by introducing this competition, you know, in a way, if you are a responder, you know that now it's no longer in your hands completely. If you do not accept, and the other responder does, the deal will go through. So your bargaining power in terms of punishing the proposer has decreased. And this can be anticipated, of course, by the proposer. So here in red, we see the game when it was played with just one responder, as before, and then in blue with two. You see that independent of the fraction of the pie offered by the proposer to the responder, pretty much across the board, so between 0 and 45, it is, except for 45, in all other proposed splits, it's always the case that the fraction of offers rejected is higher with only one responder, right? It was 100% here and 75% with two, and so on. It stays at 100% for very small splits of 95 to 5. And then, of course, the gap decreases as you move to the right. So just to say that, you know, we should be careful about and have in mind exactly how the design may or may not drive the results you find. Maybe you're inducing it by making the game skewed and sort of forcing people in one direction. The goal is to be as neutral, but at the same time as close to the problem that you want to investigate that you can. Any questions?
Sorry to ask. Why for the 45%, the amount of reduction increase in both cases?
Yeah, that is a bit of an anomaly because the prediction would be that it should always be lower. To be honest, I don't know, but these are, you know, not big numbers. You see the big gap is earlier. So here we're talking about a few outliers, I guess. But yeah, in principle, it doesn't make sense because increased competition means it should also apply at higher levels of proposals. But here, you know, we're getting so close to the equal split. You know, above the equal split, why would you even reject it? It would be crazy. The proposer is being super generous. But here we're very close to that. So I think things are a bit more noisy. The signal is very clear, I think, in this space before. Thanks. Okay. So let's talk again about coordination using this framework by looking at the crop choice. So far we've been focusing on situation when you only have one equilibrium, right? The defection. In situation when there may be more than one equilibrium, you have a different problem, right? Now the problem is no longer, you know, escaping the free riding incentives, but the problem is escaping the socially dominated equilibrium. So you see, before we actually get deep into these payoffs, but you can quickly appreciate that you could find yourself either in this rice-cassava equilibrium or in a cassava-rice equilibrium. So they're identical, except that the person doing cassava versus rice is different. And it just happens for technological reasons that one among Anil and Bala, namely Anil, is particularly good at cassava planting rather than rice. But because it's a coordination problem with social interaction, if you end up here, it may be difficult to sort of escape that equilibrium, right? It may be due to historical accidents. For instance, we are all stuck on the QWERTY keyboard, but there's a better technology. And we simply are not, it's difficult to coordinate. At some point, all societies switch, and you start building only computers with the superior keyboard that allows for typing faster. In the environment, you know, you can think of being trapped in the fossil fuel economy, or in the car example, in combustion engine cars versus electric cars. So there's a role for policy there, or maybe for social preferences again. But the point is that given independent choices that we make without thinking necessarily about the repercussions on others, we may end up on equilibrium which is not the socially optimal. If we're stuck there, there is no incentive to unilaterally change your action. So for instance, assume that you're here, you know, at the rice-cassava equilibrium. You may be contemplating, well, you know, it would be nice to go there, you know, the payoffs are better, but individually, you know, if you reason from, say, Bala's point of view, that as the sort of the payoff here in the top northeast part, the pink shaded area, you see when contemplating the switch to the other crop, there's a decrease in payoff, unless both of the players do it. And due to this individual incentive, you end up preferring to use it, which is strictly greater than 0, and the same reasoning applies to Anil. So you're stuck there, you both would like to move, but you don't know how to coordinate, and you're afraid of being in the position of the sucker. So let's talk about something more relevant to what we're interested in, climate change. So simplify the problem perhaps too much by assuming, unlike in the real situation, that with two key large players you could get enough leeway to have some solution. and end up in a situation where the worst climatic change is mitigating. So that requires both players to choose restrict, like the strategy where you mitigate quite a lot, which gives a payoff of best for both players. However, individually, say if you put yourself in the shoes of China, you always have an incentive to defect, meaning to go for the business as usual scenario, provided that the other one continues to cooperate. But that, as we know, if we do the symmetric reasoning, leads us to end up in the situation where neither wants to restrict because they can sell the goods for cheaper with the polluting technology. That's the assumption, and that is inefficient. So how do you escape that? You could do it with an emission treaty that produces the socially optimal outcome, although that also is difficult to enforce. And there's problems of not having a top-down institution, sort of a climate police, that make sure that no one deviates, right? Maybe you promise, which in a way, if you take a very cynical perspective, has been what has been happening at the last 25 or so conference of the parties. You pledge high, but then you abate not as much as you pledge. Another way to escape this sort of negative prediction is having inequality aversion or reciprocity, in which you may have then a coordination situation and you may end up on the preferable equilibrium. So let's recap what we have discussed in this lecture. We have talked about the importance of actions that are taken individually without some level of coordination, which could be as simple as communication or some kind of more formal agreement. These type of situations of independent actions that have interdependent consequences in terms of externalities can be modeled using game theory, using the concept of games where players choose best responses to other strategies. That's a rationality standard. We have analyzed the most discussed and used metaphors for cooperation and coordination that give rise to social dilemmas, notably the prisoner's dilemma and the public goods game. And we've seen that this negative prediction can be resolved by using social preferences, introducing peer punishment, that mechanism where you inflict a cost on those that perhaps didn't cooperate enough, but that is costly itself, giving rise to a second order free riding problem, or via binding agreements, provided that these can be enforced. We've also seen with the example of the ultimatum game with two responders that the rules of the game do matter. And finally, we've talked more closely about coordination situation with multiple Nash equilibria. And this will be the subject of the next slides, but you can appreciate that in this situation of coordination, political institutions, policy are key in order to steer the society towards the preferable outcome. Okay, so let me ask if there are comments or questions about these slides before I load the other ones. No? Okay, let's see if I can do the load now. Okay. Let me give it a try, but I'm rather sure this is not going to work. Okay. we ended up talking about the importance of policy in steering, especially in situation of social coordination. So let's devote the next 30 slides or so to the topics of markets efficiency when markets fail and the role of the government in correcting externalities. So let me start with a short introduction and then define more formally what externalities are and why they lead to market failures and what can be done in order to correct for such failures and for missing markets. We have seen that we can model situations of social interactions using games. We have seen the multiplicity of equilibria, and we have seen how social dilemmas make potentially these issues more manageable from the point of view of society. So broadly, about markets and why this is important, the standard economic model tends to focus on, say, sales and purchases by buyers and sellers, depending on the level of competition in these markets. For instance, the competitive market, where you set prices equal to marginal cost. But even in the standard model, without sort of environmental aspects, we have seen, if you have taken sort of Econ 101, that in many situations you are in monopolistic or oligopolistic situations where competition is not, is somehow limited, if present at all, and that has distributive issues in terms of reaching Pareto efficiency. So many situations, in fact, most common are situations where if we leave the market work by itself, under the invisible hand approach of just letting competition do the magic, we end up in these inefficient situations. So this is a very important part of real life economics and environmental economics, and so it is important to see where these inefficiencies come from, what can we do if we are a policymaker in order to correct these problems. Since we care about environmental externalities in particular, I will refer to, more formally in the next slides, to a situation of pesticide use in the Caribbean, with banana plantation owners using harmful pesticides that have these negative externalities, namely the fact that the chemicals used for increasing productivity of the plantations leaked into rivers and contaminated local seafood, and even having adverse effects on the population. So here is a classic situation where the banana plantation owners may do their economic calculus just looking at what leads to the highest production and the highest profit, but without factoring in these costs on societies. Again, it is important to stress that this is a situation where there's a missing market, the market for pollution, right? There's a cost that is imposed on society, and unless the government or someone steps in, the market allocation will be an overproduction of the polluting good, simply because plantation owners are assumed to just take into account their own profits, which is not such a bad assumption, I think, in many of these situations. You can also think in other domains why we overuse antibiotics. Again, individually, we have an incentive to perhaps just not use it wisely, because all we care about is fixing the illness at the point in time, but maybe there's no requirement, or you're already on the way to recovery. What is happening here, you're not taking full account of the external effect. The external effect is that the more we use it, the less effective it is, and the creation of bacteria-resistant pathogens, which mean that people that really need it may not find respite in the usage of antibiotics. So all these are situations of market failure, and markets generally tend to work well under private property situations in which you can specify clearly all the rights to things that are traded on the market, bought and sold, when there are properly functioning and non-corrupt institutions and governments that do a good job at quickly enforcing violations of these rights, in the court of law, for instance, when there are powerful social norms at work, so this does not need sort of top-down work, is something that has been somehow established in the population. And these are important aspects of real life as well, because they do tend to help in terms of respect of the property rights. In a functioning market, you would be able to write all the potential contingencies arising from the transaction. These enforceable contracts, in principle, would be infinitely detailed to foresee all possible situations so that they can be evaluated in the court of law. That's why, legalese is so complicated, because law language tries to encompass as many potential contingencies as possible. Of course, this is not possible to do fully, so even on that count, we often fail to some degree. Markets fail when property rights are missing or incomplete, or are simply difficult to enforce with a properly written contract. So here we will specifically address externalities, and then also look at other sources of market failure, specifically asymmetric information and the incompleteness of contracts. Then we will shift gears and try to see how to overcome these problems, both using private solutions such as bargaining among the parties, or government-mandated policies that tackle via, say, quantity or price mechanisms, tackle the overproduction of the negative good or the under-provision of the good with the positive externality. Finally, we will end this lecture with a more philosophical reflection about where should the market stop? What is acceptable in terms of interference with our daily lives, or have we gone too far in certain dimension, given the presence of markets in many aspects of life? So, depending on whether you have taken environmental economics sort of analysis, you may or may not be familiar with this diagram that looks at the production here measured in terms of tons of banana produced per year. So remember that we have two groups, right? We have the plantation owners and we have the fishermen that are somehow facing the negative externality imposed by the plantation owners' production. So they suffer a cost in terms of loss of revenue from the fish, simply because the idea that these pesticides flow into the water and cause an external cost that leads to die-off of fish. So in this simple example, we're not looking at other damages that may accrue to the population. We're focusing on the costs and the benefits from production. So the externality is the effect of an economic decision that is not specified as a benefit or a liability in the contract. So the marginal private cost, or MPC, is simply the calculus from the point of view of the plantation owner. So it is the marginal cost for an extra ton of bananas being placed on the market, right? So this is the marginal private cost. If you're a plantation owner, you see it is increasing, but not as high as the social cost. Why? Because you're only looking at your own costs that tend to increase with production, but more or less linearly. However, one should also account for the marginal external cost to society, in this case to the fishermen, that is actually non-linear. It increases more than linearly with the quantity of banana produced. You see it is done in such a way that it is quite negative for society, because it's above the private costs, at least for part of the curve. And so that allows us to define the summation of these two curves of the marginal external cost and the marginal private cost, which is the MSC, the marginal social cost, right? If you sum up these two, you get to the green line here, that is just the sum of the two and is the full cost to society. That also includes the die-off of fish that cause a loss in the income of the fishermen. So where does this market lead to, right? So we need to introduce the standard notion of price being set at marginal private cost in this competitive example of banana owner production. Note that this leads to a price which is too low, right? In terms of, because it doesn't capture that extra cost imposed on the fishermen. If you were to add these $270 that in fact could be paid directly from the fishermen to the plantation owners in order to avoid such overproduction, you would be able to do better. So that's why we're not in a Pareto efficient situation. Simply because the two parties are acting independently, and the banana owners simply care about setting price equal to marginal private cost. So you could do better than that. There's sort of money left on the table that perhaps via bargaining solution could be better distributed among the two parties. So this is the private market approach, right? And the idea is to let the two come to a solution by assigning property rights to the externality. So for instance, the right to pollute, it could also be the right to clean air, right? So this is important because in the presence of transaction costs, we will see that it does matter who you give the rights to. In the absence of transaction cost, as generally assumed in the standard model, it doesn't matter, but that is not necessarily the case. So private bargaining between parties involved will result in a Pareto efficient allocation, independent of which party has the property rights, but only provided that we are in absence of transaction costs. It may be more effective than government intervention because private parties have more of the necessary information, right? It might be very costly for the government or policymaker to actually obtain these cost figures, especially because there's an issue of information revelation from the point of view of the involved parties. Each party will try to overinflate the cost, and if you are, for instance, the plantation owners, but the same will go for the fishermen. They might say that the damage is actually higher than what it is in reality to obtain a bigger compensation. And that is difficult to monitor. It would require going at sea and actually look at the decrease in the population of the fish stock, which is subject to much uncertainty and fluctuations. As I said, transaction costs turn out to be oftentimes substantial. For instance, cost for acquiring information, enforcing the contract in the tribunal, or even just the collective action problem of getting together. This may be a particular problem for fishermen who perhaps do not have the resources or have less aligned incentives than the powerful plantation owners that, you know, they're a cartel in a way and they know very much what is best for their business. So how do you correct that externality? So in the next 2 or 3 slides, we will look at efficiency first. So by efficiency means removing the excess cost from overproduction, which in this particular example means pretty much halving production from 80,000 to just less than 40,000. And then we will discuss more distributive implications from the point of view of the two groups, the fishermen and the owners of the plantations. So, as we have already discussed, there is a net social gain that parties could share by lowering production. It would be better off, it would be best for both if there is some kind of transfer then from the fishermen that could just pay the plantation owners to produce less. That is because we have set it up in such a way that the costs increase so much that there's actually the fall in the plantation owners' payoff when reducing production is lower than the gain in fishermen's payoff. So there are two important concepts here to strike a deal, a bargaining between the two parties. From the point of view of the plantation owners, we have to consider the minimum acceptable offer, right? So that's a minimum compensation in order for them to be at least indifferent between the two scenarios. What is that level? Well, of course, it's a loss of profits arising from the reduced production. That's a shaded area here. If you move from point A to this point, you see as a plantation owner fixing the price or cost, since they're setting it a price equal to the marginal cost. That means moving yourself to this smaller quantity, and that means losing this amount of money. From the fisherman's point of view, we have to look at the reservation option. That is the maximum compensation that they're willing to pay to the owners. And that, of course, is the area under the green line, which is the net social gain, so that the extra profit that the fishermen make by having a reduced production. You see, qualitatively, you can appreciate this is bigger than the loss for the owners. And then if you sum the two, the positive and the negative, then you get to the actual net gain from this transaction. Actual compensation, of course, depends on the relative power, and by power I mean the bargaining power of the two groups. So let's talk about why this may or may not work in practice. So the limits are many for this type of solution. As we have already said, there are impediments to collective action. Again, think about the fishermen. It might be difficult to find, but also for the owners of the plantation, to find a trusted representative. And also it may be difficult to agree. You know, everything is neat in these slides, but how do you split that net gain? To agree on how to split the gains among the two parties. There's an information problem. Again, this comes back over and over, calculating the exact costs imposed on each fisherman and each plantation, contribution to pollution. The usual problem of enforcement may be difficult for a court to determine whether plantations have complied. Here it's very simple, you know, that the drop in quantity produced is observable, but in reality there's a lot of uncertainty. Maybe they work at night, maybe the measurement is imprecise, and so this has implications. And also, as I've already said, from the point of view of the sort of less powerful group or the less resourceful groups, it may be difficult to find the money that actually could pay, you know, that transfer to the to compensate them for their loss, because in this idealized setup, this, you know, happens at the same time, but most likely in the real world setting, the compensation would come first, and then only later would the fishermen enjoy the benefits of the restored production at lower levels. In that case, if they cannot anticipate the money, then they're not able to strike such a deal. So, you know, bargaining has potential to improve matters, but also has limitations. I think this is a good time for a short 15 minutes break, and then we continue with policy. But let me ask if there are questions first. Okay, see you at 1:45. Okay. Can I have your attention, please? Thank you. Okay, let's continue with the solutions to market failures. We have seen with the use of diagrams how bargaining may provide a solution to a market that is not functioning well, but we've also discussed just before the break why this may or may not be a successful approach to correcting those externalities. And also we ended up commenting this slide by stressing once again that the actual amount of compensation accruing to either the fishermen or the banana plantation owners will depend on who has the upper hand in terms of bargaining power. Now, let's imagine now a situation in which the government has the resources and the will to intervene using a policy, one of three potential policies, to correct such market failure, where the failure here, you will remember, is the overproduction of the polluting good at the level of about 8,000 tons. So you can imagine multiple ways the policymaker may go about it. One, the first and the third are more heavy-handed, top-down policies, while the second one, the Pigouvian tax on the polluting good or the subsidy on the pollution-free alternative, are more market-based in the traditional sense, so less relying on force in a way. But let's begin with a cap. So here the idea is that the government knows what the optimal level is for society. So somehow the government is aware that any production above just below 40,000 tons will be very harmful for societies. So then the goal here is to implement a cap at a socially optimal amount. And of course, we can already imagine how difficult it is to establish what the threshold is in terms of the quantity produced, but also in terms of the quota on which you bound the farmers to stop. The Pigouvian tax is a standard approach in economics. You basically apply the polluter pays principle generally in this kind of approach. By taxing firms generating the negative externality, or conversely by subsidizing the clean alternative in order to correct an inefficient market outcome. And then we will look at something that in a way is similar to what we just saw before, the bargaining solution, but here it is mandated by the government. So if you apply again the polluter pays principle, the government might say, you produce more than 40,000, that's not sustainable, you have to compensate, think about oil spillages and situation in which this has been the solution. So all of these are on the table. Let's look at them in more detail. So this is the more traditional market mechanism of using a pollution tax. Government, the idea is that in this very simple approach, the government puts a per unit tax on the level of output, and that is done in such a way as to get exactly right to the marginal social cost. So you, in a market situation without government intervention, at a given quantity, you would look at the price without the tax. Here you see, for instance, for this desired level of below 40,000, part of that 400, which is the cost at which the farmer operates, is taken by the tax. So then you have effectively internalized the externality. In other words, the profit maximizing producer chooses the output where the marginal private cost equals to the after-tax price, right? That means, you see, beginning on this was the initial equilibrium in the absence of a tax. By now equating MPC to price net of the tax, you end up at a smaller quantity here of the desired level. So, importantly for our story about who benefits in this approach, actually the tax forces producers to face the entire cost of the decision to produce. Note that this is not saying that this money is going to the fishermen. In fact, it really depends how the government uses the proceeds from such taxation. It may be that it is used to compensate the fishermen or to do other environmentally friendly or not government expenditure. So in this case, the winner in terms of wealth is the government. But the solution from a point of view of efficiency is the same. The environment is spared that extra cost due to overproduction in all this area here between 40,000 and 50,000. Questions? Okay. Now let's look at what happens in a situation of compensation, right? So this is the case in which the government forces the plantation owners to make a payment to the fishermen in compensation for each ton produced, right? So the required compensation is equal to the difference between the MSC, the marginal social cost, the green curve, and the MPC. That gives us the gray area, right? So effect is the same. You see, you get to 40,000 being produced, and that money is being transferred, forced by the government, but being transferred directly to the fishermen. So then the fishermen are fully compensated for the damage, and producers choose the desired level for PK tons of bananas. So if we compare this to what happened under a tax, you see you still get to the same level of production, but in this case, obviously, the fishermen are better off since they receive directly the payment instead of that being exercised by the government. As always, after looking at the policy, we look at the limitations of such policies. And you might not be surprised to see that they're actually quite similar to what we've been discussing in the case of the private bargaining solution. There's always the problem of missing information. Right? The government may not know the exact compensation needed to correct the problem. There's an element of measurement. Marginal social costs are actually difficult to measure, right? So here it's neatly drawn up here, but you know, in reality we have imprecise information at best about the incremental effect of more production in terms of damage on the fish. There's feedbacks, and so this signal is noisy. Something that we have not discussed much, but it is an important feature of all the economies I know of, is that of special interest groups, right? In this simple framework, you know, we didn't introduce, but you can do that actually. We didn't introduce lobbying in the sense of campaign contributions to the policymaker, but you can imagine that in deciding between option 1, 2, and 3, the government might be influenced by how much campaign contributions it has been receiving from different groups. And again, you might expect that in many real-world situations, the plantation owners may have lots of resources and even offices devoted at lobbying the incumbent policymaker. If that is the case, then it seems unlikely, for instance, that the government would choose the compensation scheme, which would effectively transfer money from the powerful group to the damaged, less powerful group of the fishermen. In this case, it could impose a Pareto efficient outcome, right? Still get to the 40K, but in a way that favors the plantation owners instead. So that's the element of fairness. So I guess more broadly, why do we even, if markets, are so good at allocating goods and services, why do we face in many real-world circumstances externalities and or external benefits, which in a way is the same type of problem, because generally goods that have external benefits tend to be underprovided. The fact often lies in the incompleteness of contracts that can be written. We have already mentioned this. So these contracts may not specify in an enforceable, policeable way every aspect of that exchange that affects the interest of all affected parties. So oftentimes much is left to good practice and trust. Contracts that include external costs or benefits are not enforceable because the relevant information is actually not verifiable or asymmetric, not known by the decision maker. If you're the government and cannot know, for instance, all the costs, estimating the marginal social cost might be difficult. This means that in reality it is impossible to use this property rights-based approach to writing contracts and make sure that all contingencies are foreseen, including the social costs and benefits arising from our individual decision making. So these are all situations of market failures, but they're not limited to the ones we have seen. This resonates with the more behavioral economics aspect of this course, but of course this definition, which granted is admittedly stark in the sense that it doesn't allow for a lot of subtlety in distinguishing between private goods and public goods, I think is still very instructive, nevertheless, in order to see what type of goods have a greater potential for market failure or incomplete markets. So on the one end of the spectrum, we are in the standard world where markets generally function relatively well, where you have contracts, there's full information. So imagine like a grocery store or a clothes shop or the market for houses. These goods are both excludable and rival. So they're rival in the sense that consumption by one of us decreases the consumption available for others, and they're non-excludable in the and they are excludable in the sense that you can exclude people from getting your grocery from the supermarket for free, right? In principle, they cannot do that. Or if it is a house, there's a fence or some kind of mechanism to avoid that it becomes a commons. Now, on the other end of the spectrum, you have the typical public good situations, such as climate change mitigation, or public lighting in the streets, or a functioning bus service, that tend to be with various degrees, but they tend to exhibit features both of non-rivalry and non-excludability, right? So it could be public goods, but also public bets, right? So it needs not be in the positive sense or negative. Both are encompassed by this type of situation, and again, noise and air pollution come to mind as examples. Now, one other special class that has received quite a bit of attention in economics and but also in the sciences is that of goods that are non-excludable but rival. So this is the situation of so-called common pool resources, and that's an example being fisheries in a lake where you cannot exclude others from adding a vessel or a fishing pole to the shared lake, or a common grazing land, which is the typical metaphor of the used in the 60s piece in Science by Garrett Hardin to talk about the incentives to add one more cow or animal on the grazing land, and that selfish calculus from the point of view of everyone leading to overuse of that grass, and then the grass not regenerating fast enough, the tragedy of the commons. But you can also imagine situations, flip situations of non-rival yet excludable goods. For instance, uncongested toll roads, that beyond a certain level of additional usage become congested. So this is a good way to organize goods, but of course a disclaimer is that oftentimes the distinction is not so crystal clear as the chart may suggest. Questions? Also, you guys on Teams, you need to demonstrate you're awake and not sleeping on your couch, so feel free, and in fact you're very encouraged to ask questions or comment as well. Okay, so as it may not sound as a surprise, public goods situations are conducive to market failures. That's why, in general standard economics, we tend to focus on the allocation of private goods that seem to work best. Especially for three types in the previous chart of goods, the CPR, the common pool resource, and the public goods game situation especially, you have that simply market cannot arise. Why is that? The non-rivalry aspect makes it so that their marginal cost is by definition zero, right? Not because they do not have an impact. If I cut down a tree or take more water from a lake for irrigation, this has impact and it's negatively, but it has to be unpriced if it is a non-rival good. So it is not possible to set, as you do in standard economic calculus, price equal to marginal cost, unless the provision is subsidized. But for that, you need the government to intervene. It is impossible to set a price for non-excludable goods because the provider cannot exclude those who haven't paid. That's by definition. So, for example, if one farmer invests in a community irrigation project, so this resonates with what we discussed in the previous lecture, other farmers receive external benefits. Right? Remember when we were looking at the payoff from me cooperating, given that 0, 1, 2, or 3 other people invest in the irrigation project, that's the external benefit part. But it is difficult to make them pay for the benefits or write contracts that guarantee a Pareto efficient irrigation level. So this we have already covered. What we haven't covered so far, or at least not in a formal way, though we mentioned in the previous part of the lecture, this aspect is the issue of asymmetric information. Now, this is very important because it is a widespread problem, and we have been studying it with economic tools for decades now. So we will talk about 2 particular cases of asymmetric information, but as the name suggests, when we talked about information that is asymmetric, the idea is that one of the 2 parties or more parties knows more relating to the transaction, if you're selling a good, for instance, about the quality of the good, or about the damage to the environment, if you're a producer of banana, than the other party does. So the first kind of asymmetric information is also widespreadly studied, especially in labor economics, is the hidden action idea that leads to the so-called moral hazard problem. So if you talk about employment, that's why this is much the focus of labor economics. Involuntary unemployment is somewhat a consequence of the fact, according to this model, that employers cannot observe the exact employee effort in a work environment. Right? So this may explain why in many circumstances there's much effort to try and monitor employees and even force them to, say, go back to the office even if the pandemic is still ongoing. This is a matter of trust and a matter of moral hazard. We will come back to this point. The second type of asymmetric information situation is relating to hidden attributes. So this is more about a good, the quality of a good. And this leads to an adverse selection problem. So the example, the classic example that comes from Nobel Prize winner economist Akerlof from the 70s is that of this kind of adverse selection where buyers of used cars do not know all the attributes of the car, right? You don't know its entire history and quality, you only see more or less how it looks. You don't know what's under the hood, and then that information is in the hands of the sellers, and they will use this strategically. But I'll come back also to this. So let's fix these ideas by using two examples. The first concerns health insurance. So imagine, it doesn't fit so well here or in Europe in general, but imagine like a US market for insurance where the decision to insure is voluntary, and if you do not, you have no coverage. If you take the viewpoint of the insurance company selling this service, it cannot observe the actual health of the people buying insurance. Since purchasers know their health status, or at least they know it more closely and precisely than the health insurance, the less healthy are more likely to buy it, right? To be profitable, however, the company must charge prices that are high enough that compensate for the fact that most of their pool of people buying insurance will not be very healthy. But that, of course, has an implication, right? Since only less healthy people are willing to buy at this relatively high price, that's the adverse selection situation where only those in poor health condition are attracted to buy this service because the premium is justifiable only in a situation where you expect a lot of expenses in the future. So that creates a problem. This is a missing market, right? So there are many healthier people who would like to buy insurance, but will remain uninsured. Now, something that maybe, if you have taken development economics or if you have been reading the literature about microfinance, this has a parallel in recent decades with microfinance, because you can think that many people still are, but in the past even more, in developing countries especially, were excluded from access to credit simply because they had no counterpart in terms of guarantees to offer for the loan. That made it so that the traditional banks were not interested in loaning money to people that they could not be sure that they would pay back the loan. Enters the Grameen Bank and then a flurry of other microfinance institutions that, by the way, are there for profit as well. They're not necessarily only moved by generosity, perhaps also by some degree of altruism, but these businesses turn out they're quite profitable. So the idea is you loan to very poor people that have no way to guarantee that they will pay back. But on average, most, not everyone, most manage to pay back because these microloans are fundamental, especially if given to the right people, oftentimes women in the family, to invest it in a productive activity that leads to a payoff, and that eventually gives rise to the repayment in the due time. So they use the more social network, social norms approach, where there would be a network of peers and people that maybe had already had success with these loans that would check on the new people. So this is just to say that sometimes markets can be created, but in many circumstances, say market for health insurance or the loans to the poorest, there's a missing market. Let's go back to the second kind of example, the car insurance one, what is also known as the market for lemons, based on this work by Akerlof and colleagues. Any form of insurance has also a hidden action problem. So this happens when the buyer may take more risks after he or she got insured. So this is interesting because generally in all our games, we have been considering strategies that are not contingent on the choice. Our payoffs are fixed, but here, in a way, the act of choosing insurance may change your incentives and may make you more risk-prone. So, in this example, purchasing full coverage against damage may make someone more careless in driving. You might speed more because you know that if you are in an accident, you're not going to be asked to pay the premium. Insurance companies can put some limits, of course, in a contract, but again, you cannot specify everything, and certainly you cannot enforce certain types of behavior, such as speeding. This is known as the moral hazard problem, which is another form of a more general class of problems known as principal agents. Whenever there's imperfect monitoring, so the employer-employee situation is also a principal agent, so the principal being the firm, the agent being the employee, and the action being the effort put in the work task, which is not fully observable. So you can think of this problem in terms of externalities as well, right? So being careful, being a good driver, gives external benefits to the company, right? Now let's bring it to more recent years. You probably all remember the 2008 crash and how it spread rapidly from the banking systems to other parts of the economies and from the US to the rest of the world. So you can also use this approach to accommodate this situation. So if you think of borrowing and lending as a principal agent problem in which the borrower's decision have external effects on the lender. That's related to the microfinance story, why poor borrowers are often credit constrained or credit excluded, which is a failure. Another form relating to this stock market crash of credit market failure is actually the way banks operate themselves. If banks take risks, or say investment banks, and go bankrupt, other banks whom they have borrowed from will bear some of the costs, right, because of this interconnected nature of interbank loans. Governments will also bail out banks that are so-called too big to fail. We have seen that with Merrill Lynch and all the big players that were in trouble back in 2008. But of course, these big players can anticipate this kind of behavior on the part of the different administrations. In fact, that was the case with the Obama administration. They saved the day without asking too many questions and too many strings attached. This in turn incentivizes risk-taking behavior on the part of banks. Questions? Comments? Teams? Silence. You guys. Okay, it's a pleasure to speak to a wall. Let's go on. Price versus marginal cost, right? We have said that in situations of perfect functioning marketing and competitiveness, pricing equals marginal cost. But firms may set price above marginal cost in situation of frictions. That could be due to limited competition, for instance, selling differentiated product, decreasing long-run average cost due to economies of scale. So that's very much important for environmental problems and environmental economics and resource economics in general, because it is a situation of natural monopoly. Whenever you have decreasing long-run average costs, you basically are in a situation where only a few, if at all, more than one, players will be profitable in the market. You know, there's only so much space for operating systems. Now we have 2 or 3, depending on how you count, that dominate the market. There's only so much space for developing oil fields in a cost-effective way. Once you have the 7 sisters or some big players, an extra player that wants to join will find it really difficult to outcompete, especially with strategic price setting on the part of OPEC countries. So this is in part strategic, but oftentimes natural monopoly, because it has very much to do with the structure of the economics of doing this business. It is very costly to develop the machinery and operate it in order to extract oil from underground, and so initially you will make a loss. So there's incentives to develop larger refinery technology, and that means big investments upfront that only pay off beyond a certain quantity produced or amount of tons of oil extracted, and so in order to get to that decreasing part of the curve, only few players have the resources to enter this market. The deadweight loss can be eliminated via price discrimination, for instance. That may lead to an unfair allocation because firms capture the entire surplus from this price discrimination, or if the government, for instance, steps in, from a policy that tries to promote competition among the firms. Okay, let's talk about whether it is even desirable to have markets allocating certain kinds of goods and services. Should they, in other words, allocate everything that we observe? I mean, on the one hand, we have seen a rapid increase in the reach and pervasiveness of markets in our day-to-day lives compared to even a few decades ago. Even though I should add that there's a big role for government still, and much of the economy still, either directly or indirectly, has to do with the government procurement, spending initiated by governments, and so we are not really, even if one may conclude, if you have taken sort of an economics curriculum, that the majority of the cases is that in which markets function and there's competition. In reality, there's much role for government, even in modern economies. But it is undisputable that compared to, say, the 70s and the 80s, the role of government has decreased. And so we should talk about how pervasive markets can and should be. So there's markets known as repugnant, where we simply, on ethical grounds, do not want, or most of us would not be comfortable with creating a market for these goods or services due to the violation of ethical or social norms. I think we can all agree that it's not a good idea to go back to slavery, and so in this case, that is simply out of the picture. Also, we should consider that not only governments tend to be effective in providing certain kinds of goods, but more traditional institutions such as families still can operate quite well outside of the domains and constraints of market mechanisms. Importantly, from a behavioral point of view, markets in certain circumstances have been shown to crowd out norms of social preferences. So we have seen how important social preferences are for decision making, but for instance, if you look at blood donation, many of us volunteer to donate blood and other resources or services or time or money. Many of these, we do it on ethical grounds, not so much for economic reasoning. So there's some experimental evidence that suggests that it may actually backfire to add to this process a financial reward, right? So for people that show up to donate blood, if you give them money, and this, especially if this is visible, right, it is observable by others, you are removing de facto a possible important reason, which is social signaling, for instance, or self-signaling, so either signaling to others how good we are or to ourselves, because being compensated in a way, confounds the two. Maybe you're doing it because you want the money. So we have to be careful about this type of introducing market mechanisms, especially in certain parts of the transaction space. Also, on ethical grounds, we may not be comfortable with having goods being provided contingent on, say, ability to pay, right? If you think about universal education, at least up to a certain point, I think most of us would agree that it should be available to everyone, independent of, our merit or our wealth. And in these cases, markets are probably not best suited to allocate education. So there's a cause and a reason for advocating for public education. Okay, let me summarize this part of the lecture. We have discussed a host of sources of market failure, external costs or benefits, asymmetric information, so the fact that maybe the action by the employees or the agents in general cannot be observed, or there are some hidden attributes to the cars or services provided, the fact that under limited competition price is above the marginal cost. We have discussed possible solutions to this, including regulation, taxation, and compensation of the most affected, negatively affected party. And then we've discussed the markets for other types of goods, both public goods and public bads, common pool resources that feature some aspect but not others of the public goods, and the limits to markets. Questions? Okay, we're going really fast given that there's so little interaction. So let me move to a different bit of slides. Okay, so tomorrow we will be playing games in class, but it is instructive to be prepared for that. So let me start sharing these slides as well. And by the way, these games work very well also online, so we will be able to do it all together so that our friends online can finally interact in some way or another. So for those that come here tomorrow, it would be good if you have either a computer, a laptop, or a tablet. Even a smartphone works, so long as it's in good working conditions, so that because you have to press things, and, but it's not heavy demand. You do not have to install. It's a web-based type of platform, so I will give you a code, and you'll be able to access for free this game. It's interactive, should be fun, and I think it's quite interesting from an education point of view, because it drives home a lot of the points, perhaps more convincingly than by looking only at the results of other people, other weird students or other people in Kenya that played the experiments before us. So I will just talk about a couple of these games we will be playing, so that we have sort of understood the rules of the game, but I think this will be relatively straightforward. But I just wanted to give you a sort of an overarching framework, so that we can get on playing tomorrow without spending too much time on the technological part of the instructions. So the first game we will play is a water purification project, so it's a public good game, really. It's going to be over multiple rounds, and the idea is that in each round, each group member receives the same amount of money. So you have, in the framework of the multi-round games we have discussed before, the repeated games, your endowment is regenerated in each of these rounds. Of course, this is not going to be really incentivized. It's sort of artificial virtual money, but please take it seriously and imagine that this money is on the line. And each player simultaneously and independently chooses how much to contribute to this purification project. You will be met with other people. As I said, it could be in the classroom if you're in classroom, but it could also be online. You don't know who is playing with you. And each individual's benefit from the project, right? Typical public good situation. And that benefit is proportional to the number of people contributing times some kind of return rate. So this is going to be the interface. At the bottom, you will see there's a number of rounds. I think we will play it with 10 rounds, but in this example, there are 5. Time, we will go over these icons, but basically the main setup is the number of rounds, the number of players. This is the rate of return, so that extra public good feature from contributing. And then you see you have a slider here that so that's why a smartphone will work, but you need to interact with these sliders. So if it's the screen is not working well, it may be a bit awkward. I've never had particular problems. Maybe one person with the phone freezing. So it's better with the bigger screen, but most manage. So your decision is in each round is how much to allocate between 0 and 20. I think it's in discrete increases of $1. And then after you have moved the slider, that will not be the final decision. It will be the provisional decision. You will be reminded here that means you're keeping 7 to yourself and you're putting 13 in the irrigation project. And then to finalize it so that it counts, you have to also press the button. So just to be sure that we are not clicking and picking something by mistake. If you want to look the history of previous rounds of contribution, so remember what we saw earlier on today, the information here is also a full information type of setup. You click on this little paper here and it tells you the contributions in the past. This is how payoffs are generated. They depend on your contribution, of course, and on the contributions of each of the other members. So let's say that you start with $20, rate of return is 50%. So for each dollar contributed by the others, you get $0.50 bonus. So if you were to have chosen in the previous slide 12 out of 20 possible contribution, your final payoff would be 18. Why? It's 20 that you start off minus your contribution plus whatever you gain from what has been given by others. So assuming that others collectively contribute, actually collectively, yes, including yours, I think, yeah, 20 euros, then you get 50% back of that. So this captures the trade-offs that we have already seen theoretically. Let's look at another example. Again, rate of return is 50%, but here we assume that the others are more generous. You see, you're better off this time, because in the previous slide, you were worse off individually by contributing. But here, even if you contribute the same amount, so you contribute 12, you get $15 back from the public good part, and so you end up with $23. We won't be playing today, but this is for tomorrow. And then we will revisit this purification project, but with a twist that we haven't really discussed theoretically about this type of game. But this is an important class of games, which is why I wanted to try it out in the lab as well, known as threshold public goods games, which in a way brings back a lot of the things that we have discussed, because a threshold public goods game is one where the project is implemented, in this case the purification project, only if total contributions are larger than a threshold. In this case, we will see how much the threshold is. If you do not collect enough money, you simply do not do the project. So it's a different class of game. You can imagine also because it has different strategic repercussions, but also, in the previous one, it's linear public goods game because, the more contribute, the better for everyone. In this one, the idea that if you don't get there, you simply do not do it. We have seen this kind of public goods when we donate to a project that only materializes if we get to that threshold level. So in a way that makes it more salient, the threshold, right? It's easier to get there. And that is strategically because it transforms this game into a coordination situation. So there's still the free riding equilibrium, but there's also the cooperative equilibrium of getting just to the threshold. Anyway, we'll see how that if that takes place or not in class. But everything else is the same. The only difference is the one underlined. So the setup is the same, but you see now you also have information about the threshold, which is in this case fixed at $50. So let's look at the example. Again, your contribution, your payoff depends both on yours and the other contributions, but also the excess contributions lost and the insufficient contributions lost. So there's multiple ways, going back to different rules of the games, that you could do it. You could do it in a way where you refund people. If it doesn't happen, okay, your money back. In this version, which is quite stark, and it incentivizes contributions quite a bit, you know, every contribution above the threshold is lost, it's unnecessary. But also, if you say collectively contribute $48, that's the worst possible situation, because you don't get to 50, that means that money is gone. So it doesn't even produce the public good. So in this new example, you start again with $20, the project is worth $50, and the rate of return on the public good is 30%. So if you were to have contributed $12 out of the 45 contributed in total, then you would end up with only 8. You start with 20 net of your contributions, but remember, you stop at 45, so you don't get to the threshold. So that means, sadly, that you do not gain anything back from the public good. So you see, this is really bad outcome, miscoordination. But strategically, this would make it, in a way, easier to get to 50. We'll see whether that is the case or not. Okay, then let me introduce the third type of game we will play. Then I will stop, because otherwise we may start to forget all these different rules. This is a classic fishery game, so a common pool resource game where there's rivalry, but you cannot exclude other fishermen for coming to the lake and trying their luck, right? So here the rounds can be interpreted as different seasons of fishing, and you're initiated with a given number of fish in the lake. Your decision in each season is to choose how many to catch. And at the end of the season, this is important because there's a dynamic element. Unlike in other games we have looked at, here there's a natural resource, right? So there's a social dynamic, how much you take out, but also there's the regeneration rate. So that's more like a ecological dynamic. So you're coupling two dynamics, social and ecological. The remaining fish double. Why that? We assume that there's a reproduction rate and that fish in the next season, say next year, will double. Of course, there's a cap on how many fish can be sustained in a given lake of a given size. That's the carrying capacity, right? So that will also be a constraining factor. Even if you do not fish at all, the population will never go above a certain level. There's just not enough resource in terms of water and plankton and nutrients in the lake. At the end of the game, to avoid this end of game effect where everyone just rushes to the resource, the idea that the fish is doubled still, so they continue to reproduce, and then whatever fish is left in the season after the last, you get your share. So you split evenly the gains from whatever is left in the pond. So your payoff is given by two parts. What you catch, of course, the more you catch, the more you make money because you sell it on the market, plus the end of game fish, whatever is left at the end. So let's familiarize with the interface that we will see tomorrow. Again, familiar number of rounds, number of players. This is new, right? The beginning of that given season. So this is the first round. So this is the very beginning. The number of fish that are in that lake or pond or sea. Sorry. So that's actually the carrying capacity, right? So you know that if you were to harvest 80 of these fish In the next season, season 2, sounds like a Netflix episode, you will have again 160 fish in the pond, right? So that's the carrying capacity, 160. And this is to remind yourself, so each of you will see a different value, unless they fish identically, the number of fish that you have already caught in that season. So if I remember well, with the mouse you click to fish, and then there's either you wait until the round is over, or there's some button that you can play to say that you're done fishing for that season. When everyone plays or when the time expires, the season ends.
And sorry, the maximum capacity would be 160 in this case, like the logical.
Yes, in this case it is. I had to check if I will initiate it with you on the same number, but it will be clear and you will be reminded. Yeah. So that means if you go above 80, if you fish more than 80 in the next season, you will have fewer than 160. If you go to 0, in fact, next season there will be no fish. You will just stare at an empty screen. So yeah, this is how you fish. You click on your vessel once, and then either you stop fishing or there's this other button that I will check that tells the computer that you're done. So let's look at an example for fishers on a lake. So n equals to 4. In this case, actually, it's not 160 but 80, the carrying capacity. Let's assume that in this particular round or season you have caught 85 fish. And in the final season, sorry, not in this particular round, it's impossible because the capacity is 80. Over all the rounds prior to the last one, you have caught, you with your vessel have caught 85 fish. And then it's a final season and you personally catch 25, leaving 30 in the lake. So the payoff would be what you have caught in the previous rounds, what you have caught in the last round, double the number of fish still in the lake in the last round, divided by 4 because you're splitting it with 4 other players. That's 125. Okay, I will stop here in terms of rules, and then tomorrow we will be actually playing these games, so hopefully this will be fun as well. Any questions? Okay, then I will see you tomorrow, same time, 12:30. Thank you.
Thank you. Bye.
Bye-bye.
Thank you. Bye.